primarily an update on what we have been busy with in terms of the data and the images and the progress we have made since last time. And I'm going to start with an overview of the data pipeline that I've introduced in more detail last time, but just to give you kind of a refresher of how we work with your collections data. So the first step is obtaining the input data, which we have in both XML format as well as Excel tables. And we go through several steps of conversion and curation, which is mainly aligning some entities with reference data, for example, persons, but also geographic places, and do some light data cleaning. We don't intend to do too much manual cleaning because this is the steps we need to then repeat again when the data updates. So we mainly do the person alignments and just getting everything into shape. The images, we have the images from the Zentralbibliothek already online on Erara and eManuscripta with the IIIF API. And the images from the Nationalbibliothek currently live on Wikimedia. And the images from the Stiftung Fellmann we have on as files, so they are not currently online. But what we do in this step is we extract some image data, for example, size and location, and integrate it with our source data. Then we have a pre-processing step in which we prepare the source data for conversion into linked data. This involves mainly integrating the curated data from the different platforms, integrating the image data, as well as some interpretations, especially date specifications. We have free text date specifications, which we convert into machine readable dates and then convert it into CDOC CRM. Then the actual conversion, what you see on the left side is an editor, which we use to make a mapping which describes how to convert each field from the input data into a linked data representation, which is what you see on the right. We then ingest this into a database and we do some post-processing, which is mainly some cleaning up, but also obtaining data from external resources. So we aligned, for example, persons and places with Wikidata, with GND. And in this step, we also integrate some data from GND and Wikidata into the platform. For example, the coordinates of places, so we can do some map visualizations or biographical information on the person, such as person death date, or as you see here, the portrait images. So just to give you an overview of the whole pipeline. The data model, this was our original data model for translating every input field into a node in this network. We have since simplified the view a bit, but the basic components are we have physical object, which is the actual page document with the print, which carries a visual item for the image, the artwork. So we kind of discriminate the physical from the conceptual artwork. And the conceptual artwork can represent things, for example, places, actors, but also events such as festivities. And this is what we model here. And we model two types of creation. So the artistic creation, which is the art and the painting and the drawing, as well as the production, which is the printing and everything associated with it. So these are the nodes which are here on the right side. So this is the basic framework of this model. Alongside, on the downside, we have other metadata fields, such as the physical dimensions, the material, or any other tagging we obtained from the source data. So one aspect we focused on since last time was, as Stephanie noted, the process around print production. So what we tend to do is to model this and represent this in better detail. So what we set out to do is to describe the ideal model that we would like to have. So we have, again, the physical print, which has been produced to a printing process. And this printing process, for example, used a printing plate, which again was produced in a process which we call engraving, which was carried out by a person, which we call the engraver. And this process of engraving probably used a specific object, which is the original sketch or the template created by an artist. So in principle, this is how we could model this process. We also have a process here called publishing, and we were thinking how we represent this. So we can say that the production of the print was motivated by the act of publishing. Publishing, of course, is quite a complex activity, but we thought that this is kind of a simple way to represent that. Similarly, the process of coloring is a modification of the finished print, which has again been carried out by a person. So this is what we came up with in how to represent this print process and the modification thereof. We have, however, two problems. The first one is we don't know all this. We don't have complete knowledge of which printing plate is used and which sketch is used and how this process is exactly derived. So if we represent it in this way, we are risking to be too precise. So we make statements that are not actually founded in the evidence that we have. And the other problem is that we, of course, cannot do this kind of analysis to all 30,000 images. So we have different levels of detail, some prints which we will analyze in great detail, others where we have a more common knowledge. So based on this and our model before, we then derived a harmonized model in which we have these two production processes we have before. So the production of the physical object and the creation of the conceptual artwork. And we treat all these processes, coloring, printing, engraving, publishing, as sub-processes of this production. So we have one general production, and it can consist of printing, of engraving, of coloring. And when we know more about this process, we can add it to these notes here. So we can add, for example, the template used or the printing plate used. But if we do not know it, then we can already convert the data we have. For example, we have the person who did the engraving. We can convert this into engraving production done by a person. So in this way, harmonize kind of a detailed knowledge that we will be able to obtain with the more general knowledge that we derive from the data. The other addition to our data model was the parents' data from the Nationalbibliothek. So in the archives of the Nationalbibliothek, we have a hierarchical organization of dossiers and collections, which then contain documents. And in our data, we already had for every document, this document level, the parent identifier. So we knew of the existence of a parent element, but we did not know anything else about it. So we could already add this connection that we have a physical object which forms part of another physical object, which can be, the dossier collection. And since last time, we also received the parent data from the Nationalbibliothek. So we have the records for the parents. So here is the level of the SARI. And this means we basically reapplied the same mapping. We didn't need to change it. And now we also have a view of the individual dossiers in the platform. This is the hierarchy. So for example, we have this Voyage Pittoresque, which forms part of the Alben Mappenwerke, which again forms part of the Hugelmann archive, and so on. We now also have some records on collections. We don't yet have actual images. So we have the structure of the full collection, but we don't have all the images. But I think that's kind of, it's better to know of the existence of other things, and the Bilder der Schweiz platform focuses on a specific collection, and we're not intending to reproduce the entire collection of the Nationalbibliothek, of course. So this is what we added in terms of the mapping. We added this type, which we derived from the document level, and we classified this as subgroups. So we can now also navigate and search through this collection by the archival divisions. We also worked on the conversion mapping of the Zentralbibliothek data. And the Zentralbibliothek uses MARC 21. And what we did is we went through each subfield in MARC 21 and translated it into mapping to CDOC CRM. So this means, for example, for the personal name, we made a mapping to represent that. And then we translated it into a conversion method. And the problem that we had is that this became really big, because we have, for every subfield, we have a single mapping, and it becomes a bit hard to maintain and to understand what is going on. So we decided to revisit it with better knowledge of the collection schema. Because if you know MARC 21, there are some structural similarities. For example, there are the fields 100 and 110, which refer to the person or the corporation creating the artifact, and there is a 707 and 10, which refer to other persons associated with it. And these fields are structurally similar. So we have, for example, subfield A, which is the name, whether it's the personal or corporate name, and so on. So this is what we can use to kind of organize our mapping closer to the MARC structure. So we can make a single mapping for all the MARC fields which are similar, and then we only need to treat the exceptions to it. And the exceptions can be quite complicated. For example, in the field 700, we have the subfield 4, which describes the relationship, and the Zentralbibliothek uses codes to say, okay, it's the artist, engraver, publisher, former owner, there are many more. Now, if you translate this to a linked data model, these persons end up in very different places. For example, the artist is up here in the creation of the visual item. The engraver, as you see, is here in the production. And the former owner is here. We have an acquisition process, which basically brought this object into the collection of the Zentralbibliothek, and it was acquired from an former owner. So these individual fields can be quite complex to map, and with kind of mirroring the MARC structure more closely, we were able to make a bit of a more maintainable mapping. Data cleaning, I will not go too much into detail, but where we spent some time is on consolidating actors. So previously we had persons which should have been the same, which were not, so we managed to merge them. We focus on the roles, so the roles of printing or engraving, we cleaned that up. We aligned those with AAT, which means we have also harmonized terms for these roles. And we did some cleaning of the places, but this is still an area where we want to focus on to really represent these place hierarchies. Where we did a lot of work was with the images themselves. And here we had two tasks. So as Stephanie mentioned, we collaborate with Snapshot for locating images in geographic landscapes. Now, not all images that we have lend themselves. So for example, we have images which really depict landscapes, and we have images which depict social life or other things which we cannot easily, which we cannot locate in a map. So we need to identify the landscapes in this collection of 30,000 images, and we did not intend to do it manually because we would never finish. And the other task is image segmentation. So you see that we have, in this example, we have the print itself on the document with the background and this calibration bar. For display, we would like to be able to focus on the image itself, but without getting rid of the outside artifacts. So the image classification, we tried to use an off-the-shelf machine learning model because there are models that can tag landscapes and objects, but it was just tagging everything as a postcard because it saw the document and didn't recognize the landscape. And the other thing is that we don't necessarily want landscapes, but we want landscapes that we can classify in snapshots, which means images that have landmarks that we can locate in a landscape. So yes, we had to start from scratch. So the first thing, we made a training set. So we labeled 2,000 images as either landscape or not landscape. And this was a randomized selection from all the 30,000 images. We then trained a machine learning model, and there's a big collection of models available, and they're always updating, but there's this fast AI models which are quite easy to train. And we just trained a classifier which can discriminate landscapes from not landscapes. And we used Google Colab, which is a machine learning notebook platform by Google. So you can execute it without having expensive hardware. So then we ran this model on our own computers. We classified all the 30,000 images, and I think we identified about 10,000 candidate landscapes. Because we want to have everything in the knowledge graph, we then also converted this classification result to CDOC-RDF. So we treat this as attribute assignments, which assign attribute to an object, either landscape or not landscape. And we also link to the specific model that we use. So we can, for example, also improve this model later on or have different types of classifications. And we have it all in the graph. The image segmentation is also a task that is quite common in this area of image processing. And here we used a generic model developed by the DH lab at EFBFL. It's called DH segment. Again, there are tons of methods we can use, but this is one that is well documented and has already been used with this specific task that we have in mind. But it's always better to do a bit of extra training on our own images. So here we used Runway ML to define regions in these images. So we have the image, the document, and the color bar that we marked up in, I think, about actually only a few hundred images. So we didn't need that many training images. And again, we create the training data, and this is how it looks for DH segment. You get the input image and the kind of label image with this colored blocks. And we can then train the model using our labeled data, and we obtain a model that we can apply on the image. And as you can see here, we only extracted the actual image. So this can now identify where the image is located in a document. The next step is to also put this on the platform. Again, here we wanted to do it not the easy way, because the easy way was just cutting the images. Instead, what we wanted to do is to use IIIF to really address the regions of these images. And here we ran into a bit of a rabbit hole because not all images are on IIIF, and Wikimedia images, they wanted to implement IIIF by the end of the year, but it doesn't look like they've done so. So we did our own IIIF implementation. I'll show it to you in the second part. So we can now also get the images of the Nationalbibliothek in IIIF. And next step would then be to ingest also these image regions. The actual models are also available on GitHub. We currently have it private for the only reason that there are also the images itself in there, but not the images itself, but the links to the images. But with your permission, we could also open this up. The images are all online. So if you want to have your own go at the image classification, image segmentation, you can use these models and maybe improve on it